Willow's quantum leap, a new computational dawn. Google's quantum chip named Willow has arrived. Its appearance marks a truly significant moment in science. The field of quantum computing is a new frontier. Willow stands at its very edge, ready to explore. This chip is not just a minor improvement on old ideas, it represents a fundamental shift in how we think about calculation. Scientists around the globe are incredibly excited by its potential. The entire world is watching closely, anticipating the changes it might bring. Indeed, this remarkable device could alter everything we currently understand about the power and limits of computers. On December 9, 2024, Willow performed a highly complex task at an astonishing speed. This calculation was meticulously designed to push quantum processors to their limits. Willow completed this demanding challenge in just a few minutes. This was a stunning demonstration of its advanced capabilities. Many observers were left in sheer awe of its processing velocity. To truly appreciate Willow's feat, we must compare its speed with traditional supercomputers. The task Willow solved in minutes would take these classical machines an estimated 10 septillion years. This staggering difference highlights the immense scale of Willow's advancement. Google has demonstrated a way to make quantum systems more robust and reliable. This resilience is key to building practical, fault-tolerant quantum computers for the future. The particular challenge Willow conquered is known as the random circuit sampling test. You can imagine this test as an incredibly intricate maze. The quantum computer must navigate through a complex web of random quantum circuits. After traversing this maze, it must then sample the outputs. This process helps scientists to understand the underlying behavior of the circuit itself. The RCS problem is a very specific type of computational task. It is intentionally designed to be overwhelmingly difficult for any standard classical computer to solve within a reasonable time frame. Willow, however, navigated this quantum gauntlet with remarkable efficiency. Its performance in the RCS test clearly demonstrated its quantum advantage over classical systems. The difficulty of the RCS task grows at an exponential rate for classical machines. As the circuit size increases, the problem quickly becomes impossible for them. For Willow, with its quantum architecture, the problem remained manageable. The details of this significant success were shared with the wider scientific community. The findings were published in the prestigious journal, ensuring that researchers worldwide took careful note of Google's progress. Successfully completing such a test proves the concept of quantum supremacy for this specific task. The very idea of a multiverse stretches the imagination. Our universe might not be the only one. There could be countless other universes. Each quantum event might create new universes. This idea comes from theoretical physics. Some scientists believe it could be true. Willow's performance might be linked to this theory. Experts see a potential link. Willow's power might draw on something beyond our universe. Could Willow be tapping into parallel universes? This bold claim sparks intense debate. The many worlds interpretation of quantum mechanics, proposed in the 1950s by Hugh Everett III, every quantum measurement splits the universe. Hartmut Neven, founder of Google's Quantum AI Lab, suggests Willow's success points to parallel universes. His team supports the many worlds interpretation of quantum mechanics. Neven's ideas echo David Deutsch's theories from the 1980s. Deutsch proposed quantum computers might use parallel universes for calculations. Alright folks, here we are in section 5, diving into the heart of quantum mechanics, superposition, and entangled universes. To really get how Willow might connect to other universes, we've got to first wrap our heads around quantum superposition. So, imagine you're tossing a coin high into the air. While it's spinning, before it lands, it's not just heads or tails. Nope, it's in this kind of limbo state. Now, qubits, the building blocks of quantum computers, are kind of like that spinning coin. They can be a 0, a 1, or importantly, both 0 and 1 at the exact same time. This characteristic of bothness is what physicists call superposition. It's a fundamental and, well, pretty mysterious property of the quantum world. It's precisely this property that makes quantum computers so profoundly different from classical ones. Willow's qubits make extensive use of this principle of superposition. Each individual qubit within the Willow chip has the capacity to represent multiple values simultaneously. This unique ability allows Willow to explore a vast number of computational possibilities all at once in parallel. A classical bit, by contrast, is strictly limited. It can only be either a 0 or a 1 at any given moment. A qubit, thanks to superposition, can hold and process much more information. Section 6. A chorus of caution, skepticism, and alternative quantum views. It's essential to acknowledge that not everyone in the scientific community agrees with the multiverse interpretation, especially concerning Willow. Many highly respected scientists remain deeply skeptical of this connection. They firmly believe that there are other, perhaps less extravagant ways to explain the peculiar rules of quantum mechanics. The multiverse hypothesis is not the only interpretational framework available to physicists. It is crucial in science to consider these dissenting voices and alternative viewpoints. Genuine scientific progress thrives on rigorous debate, critical examination of evidence, and a healthy dose of skepticism. One notable critic of the multiverse linkage is the physicist and science writer Ethan Siegel. He, along with others, points to well-established alternative interpretations of quantum mechanics. For example, the Copenhagen interpretation, one of the oldest and most widely taught, describes quantum systems in terms of probabilities without invoking other universes. Then there are pilot wave theories, which suggest particles are guided by underlying hidden waves. These theories can explain quantum phenomena perfectly well, without the need to postulate the existence of countless other worlds. They offer different yet coherent pictures of quantum reality. The multiverse is just one compelling option among several. Furthermore, some criticisms have been leveled at the random circuit sampling (RCS) test itself. Section 7. The Willow effect, weaving a new technological tapestry. Regardless of the ongoing debate about multiverses, Google's Willow chip is undeniably a game-changer for technology. Its demonstrated speed and improved accuracy are truly remarkable achievements in their own right. This breakthrough will undoubtedly accelerate the pace of quantum innovation across the board. It opens up entirely new doors to previously unimaginable possibilities in computation. A wide array of scientific and industrial fields stand to benefit enormously from access to this new level of processing power. We're only just beginning to glimpse the vast potential that quantum computing holds for the future of technology. One exciting prospect is the development of hybrid AI systems. Willow, and chips like it, could enable entirely new forms of artificial intelligence. These advanced systems would cleverly combine the strengths of both quantum and classical computing architectures. Classical computers are already very good at performing certain types of tasks efficiently. Quantum computers, on the other hand, are expected to excel at different, often more complex kinds of problems. By working in tandem, these hybrid systems could become incredibly powerful tools. This synergy could revolutionize fields such as machine learning, data analysis, and fundamental AI research. The applications of this enhanced computational power could extend into numerous diverse fields. Section 8. Peering into the quantum future, promises and potential pitfalls. Looking ahead, Google has ambitious plans for its quantum computing program. The company aims to construct even larger and more powerful quantum computers in the coming years. There is talk of creating large stacks of supercooled quantum computing systems. Some projections even envision harnessing the collective power of up to 1 million quantum bits, or qubits. This represents an enormous leap from the capabilities of current-generation systems. If Google and its competitors are successful in achieving this scale, it would unlock truly transformative computational power, capable of tackling problems far beyond our current reach. The ambition driving this research is immense. Regarding the timeline for more widespread practical applications, many experts in the field are optimistic. They expect to see quantum computers begin to solve more real-world, commercially relevant problems by the end of this decade. We are steadily moving from a phase of primarily theoretical exploration and experimental benchmarking towards an era of practical utility. This means that quantum computers will soon start to provide solutions for actual challenges faced by industries. These will likely be problems that are currently considered intractable for even the most powerful classical supercomputers. This transition will mark a significant shift for businesses and scientific research globally. It is also important to note that Google is not alone in this quantum quest. Section 9. A milestone in millennia, Willow's scientific significance. Willow's achievement is a significant milestone in scientific history. Like Galileo's heliocentric model, it challenges our understanding. Quantum computing redefines computation and reality. Willow exemplifies this transformative progress. It stands as a testament to human ingenuity and curiosity.